Check 1 2. Check 1 2. All right. How do I stop? Do I press stop for stop? All right. So I guess it's recording now. Let's collect some data. So this is without any this is just the mass hanging. And then let's pick up the mass, and it should zero out. And I'm going to drop the mass in 3 2 1. There we go. All right, so that's unimpressive, but I think that you'll have more. There we go. That's more like it. All right, so why didn't it go down to 0 exactly? Well, because the ring on there is a certain thing, a certain weight plus the string. Almost negligible, but not negligible completely. It got 0, and then you have, it's interesting because it has this spike, and then it went down to actually less than the ring, and it has a second spike, and it comes down. And then it almost looks like periodic motion. Yeah, that's definitely the bounce. What I thought is interesting is, why is the second spike bigger than the first spike?
Why is it, Mr. Dalday?
I think it's because this. We have it recording at 10 hertz. That means it's going to go 10 times per second. We can up this sensor to go to 100 hertz. So maybe what it did, we can even go to 1,000 hertz. That's a lot, but we go to 100 hertz. So maybe what happens is, maybe it blipped right here, and then like the next blip, it was already down. But maybe this thing, I suspect that this bump should be higher than the other second bump. But maybe it just happened to catch it when it's not at its peak, but when it's like going up or down or whatever. You know what I mean?
Should we do it again?
We can do it again with 100 hertz. So ready? So this is it hanging.
Okay.
We'll just let it hang.
Okay.
So that's it hanging. And then pick it up. There we go.
Drop it.
All right, 1 2 3. There we go.
Pretty.
That one goes up a lot higher. And I think that the reasoning for that is because we got a higher sampling rate. Does that make sense? All right, cool.